We'll start with number 1. If this equation has no solutions, what must be the value of a? So the key in these kinds of problems where you have this left side equal to this right side, you've got one variable, which is x, and more than one, or even just one constant, in this case a and b. The idea here is what needs to happen for this to have no solutions, or as we'll see in a minute, infinite solutions, is whatever the value of a is, whatever the value of b is, when I go ahead and try to solve this equation, what we want to happen is we want the x terms to cancel out. Because then what we'll be left with is something like, 2 equals 4, or 0 equals negative 6, or something, in the case of no solutions, which is not true. And that shows us it's a no solutions case. Or if we get something like 3 equals 3, or negative 2 equals negative 2, after that x term cancels out, we know we have infinite solutions. But in both cases, what needs to happen is I need ultimately this term to equal this term, so that when I subtract them from both sides, they cancel. So really, the first thing I'm going to do here, let's distribute these values. So it's going to be 1/2 ax minus 8a equals 3x plus 3/2 b. For now, we can ignore these constant terms because all we really care about are these terms with the x. And so what I need to have happen is I need for this coefficient to equal this one. And so I can just set up a quick equation here. I can say 1/2 a is equal to 3. And so a is 6. And that is the value that a must be so that this equation has no solutions. And just as a test, let's plug that 6 in for a. So 1/2 times 6 is 3x minus 48 is equal to 3x plus 3/2 b. And again, we'll deal with this term in a moment. But regardless of what's going on with that term, notice when I subtract 3x from both sides, cancel, cancel, I'm left with negative 48 equals 3/2 b. And what happens from this point on depends on the value of b. And this is where the second question comes in. So for part 1, we know a is 6, and a is definitely has to be 6 if this has no solutions. But again, if it has infinite solutions, it's also the case that a must be 6. So when you're dealing with the coefficient next to the x, whether it's no or infinite solutions doesn't really matter. We need those x terms to cancel out. But here's where this constant term comes in. In order for these equations to have infinite solutions, as we said before, right, with 3 equals 3 or negative 2 equals negative 2, I need for this final equation, like what we're left with when the 3x's cancel, I need for that to be equal in order to have infinite solutions. So I can just solve this for b. So let's multiply both sides by 2/3. So I'm going to get b is equal to, cancels a 3 here, we've got negative 16. Negative 16 times 2 is negative 32. So this must be the value of b if we're going to have infinite solutions. Infinite solutions. And again, we can test this out. Let's plug this in to our equation we had over here. So it's 3x minus 48 is equal to 3x times, or plus, 3/2 times negative 32. And when we simplify the right side, multiply that out, we get exactly minus 48. So we have the same equation on both sides. That's one indication that you have, or the same expression on both sides. That's one indication we have infinite solutions. But now if I subtract off the 3x's, they cancel. I'm left with negative 48 equals negative 48. Even if you added 48 to both sides, you'd get 0 equals 0. Either way, this is the infinite solutions case. And so if this is the infinite solutions case, what has to be true about b for there to be no solutions? Basically, b can be anything other than negative 32 if we want no solutions, right? So if b is anything other than negative 32, if b does not equal negative 32, that is going to be our no solutions case. Because, let's just do an example here. If we plug in, let's pick a value for b, 16. If we plug that in for the value in our equation, so we have 3x minus 48 is equal to 3x plus, so again, I pick 16. So 3/2 times 16 is 24. If I go ahead and try to solve this equation the normal way, we get negative 48 equals 24. And no matter how you manipulate this, you're going to get an equation which is not an equation, right? These are not equal to each other, and this is the no solution case. So this is not a question that was asked here, but if you needed to know like what is true about b, if it has no solutions, then b can be any number except for negative 32. And another way we can think about this is to imagine these were two separate equations, both equal to y. And I'm actually going to go to this version we had here, right? If I had y equals 3x minus 48, and then I had another y equals 3x minus 48. Zoom out a little bit, we see if I toggle the blue line on and off, I just have the same line twice. This is that infinite solutions case. But again, if this number here, depending on the value of b, if this number here, if this y-intercept is anything other than negative 48 after we plug in our value of b, right? If b is anything other than negative 32, for example, if b were 16, right? Go to this case, if b is 16, we get 24 for this term. So if we put in 24 here, what happens? Now we've got two parallel lines that are, of course, not intersecting ever, and therefore no solutions to this system. So we can also think of this graphically as well. But on these problems, what I like to do, again, if we're trying to figure out whether it's no or infinite solutions, just make sure these x terms are equal so that they cancel out. And then whatever's going on with what's left will tell you whether it's no solutions or infinite solutions. But in this case, for the first question, we get a is equal to 6. And for the second question, we get b is equal to negative 32.